それでは時間になりましたので、次のセッションを始めさせていただきます。次は、マイヤーさんの発表で、スカラ3とスカラ CLI でデータプロジェクトの生産性を向上させる方法です。では、マイヤーさん、よろしくお願いします。
Thank you. Hi, everyone. So my talk is going to be about productivity, or the full title is the productivity booster for your data projects with Scala3 and Scala CLI. So mainly we will talk about productivity and about those two toolings in the context of data projects. Few words to me. Konnichiwa. I'm Kolja. In my day-to-day work, I'm a data and ML, so machine learning engineer at Innovex. That's a German-based company, and I have roughly 10 years of Scala experience. So as I said, this talk is basically twofold. So let's start with the first part. Big data is big in various ways, and it's like a broad topic in its own. So I thought I will kind of boil it down to some of the most prominent components, or where I also within my working life collected the most experience. And this slide is named Battle-Proof Architecture because I think the components you see on that slide are quite known and really powerful to do all sorts of data engineering, but also ML engineering and in general data project things. So on the left we have Kafka. You probably know that. That's maybe can describe it best as a distributed queuing system where you can store your data and have different topics to pass messages on them. In the middle, you have Apache Spark. Probably many people know it. Actually, how many of you maybe have been working with Spark? Maybe raise your hands. Be interesting. Not that many. Okay, thank you. And on the very right, this is just from the icon, probably hard to decode. So this is BigQuery. Maybe some of you know it. It's from the Google Cloud platform. This is basically a cloud data warehouse. So I just picked it because I like it, but of course you can just plug in any other data warehouse. And so with this chain, you really have, you can sort of think in capabilities, and with those capabilities, you can really do lots of stuff, right? With Spark, you have streaming and batch job capabilities. You can transform your data and then eventually store it in your database in that case, in your in BigQuery concretely, and from there make it accessible for your end customers who will consume the data and do different sorts of other jobs with it. And of course, what is also really important, of course, for such a battle-proof architecture is that it's really interoperable. So you can go back and forth between the systems. You could even draw an arrow from Kafka to BigQuery because they're also fitting really well together. So yeah, these are the building blocks, so to say, for that talk in terms of big data or the components that we are using here. Also later we will see them in the examples, of course. And of course, you might know Kafka and also Spark has its roots in the Scala language, which is awesome because while the PySpark integration or PySpark client is also really good, you sometimes have more power to leverage the actual Scala APIs from Spark because you just have brand new features in it, and that's also a nice benefit. All right, so the other half is about productivity. So what do I mean by that? I brought a few examples because I think it's now also Scala3 is roughly 3 years old, but it's still worth mentioning some of those really cool features. At least those are like basically the top features from my point of view, or which I think also makes me or maybe also others very productive. In general, as you probably know, there was a huge rework on the whole syntax. So it's you have the option now to go without braces, which maybe is also easier to pick up for someone who is coming from a Python background. Of course, in the whole data ecosystem, you also have a huge percentage of people who are using Python. So it's really astonishing, actually, sometimes how close Python and Scala code can look nowadays. So this is really nice to have. Also, enums, really huge new feature that's valuable, makes you more productive. You can probably most of you used it in the past. We had the capacity to implement enums, but it was maybe a little verbose with sealed traits and stuff like that. So enums is really nice to have. Also top-level devs, especially for let's say maybe POCs or quickly experimenting with things. It's really nice and straightforward to have top-level definitions instead of, I don't know, creating your package objects where you define again objects to then access in another file. So yeah, definitely also a productivity hack to just use the top-level definitions when applicable. What's not so much about the language, but what I also really appreciate, and I think it's in the end also brings productivity to us all, is the release cycle. So I think those were also just recently adapted to have that the languages, I think, released every 6 weeks with some new improvements, and I think this is really cool that we have that. And last but not least, the Scala CLI. Indeed, last but not least, because it's just, I put it in the end because it will be a smooth transition now. And this is really, I think, a really important tool to kick off your journey as a Scala developer who didn't hear about Scala before. And was yesterday talking with Jamie that we also get it in the future. We just have it in Scala, the comment itself. It will be Scala CLI. I think this is really nice because all the capabilities that we found in Scala CLI, we can then also just use when typing Scala on the terminal. All right, so now let's go over the examples, which are exactly tackling those features that I just mentioned with the big data context, or also the libraries that we saw within Scala CLI. So first, Spark. I don't know about you, so I didn't see many hands, but I can tell you from experience, it wasn't always that easy to set up Spark on your local machine, and still it's very, I mean, it's the essence of productivity that you can iterate locally, that you can really experiment, that you can try out something quickly and discard or iterate on it and bring into production later then. And the nice thing about Scala CLI, we even have the Spark option. So much of the hassle of setting up Spark itself is taken from your shoulders, which is amazing. And productivity, I mean, we all know it, autocomplete in the IDE, and this you get then, of course, also out of the box when you kick off your Scala CLI program in Spark. So here in that example, we just get a really nice speaking documentation right from the Spark library. And don't worry, this is not at all a talk about Spark, but just to highlight that you can really easily, like I said, locally iterate on your program. So here, for example, we have some data set about people, and we just group by it, map over it, and it's really easily done. Afterwards, we generate some statistics. Over here is the aggregation, and then we end up with the data set in Spark. So really easy to do. A few lines of code. It's really in one file. By the way, later I will share with you a QR code so you can check all of these examples on my GitHub. But for the matter of time, it's of course just trimmed down to the sense here. Of course, you then can also use the Spark SQL capabilities. So in Spark, you might know you have the two options to basically go the programmatic route. That's what we've just seen with all your methods in place, and then basically calling dot and then chaining the next call. Or you can also just go to SQL, if that's what you like to do, and you can experiment also with that just locally. What is necessary for this? So in Scala CLI, you have a thing called directives, which basically are meta instructions. So on the first line here, we see it should use Scala3, which is in itself also really great because Spark itself is not actually written in Scala3, but 2.13. But this nice library from line 3 actually gives us the capability that we can use the full power also in Scala3. So it's doing some magic around the implicits that are not available out of the box for Scala3 yet. Hopefully Spark will move to Scala3 in the future, but for now you can help yourself with that one. And after doing the imports, you can basically just kick off the code as I put it down here. And again, check out the code if you're interested in more detail. I will share the link later. So next component, BigQuery UDFs. UDFs, first of all, it's a user-defined function. So BigQuery you can imagine as an SQL interface. You can have your normal SQL in there. But for, let's say, advanced and custom functionalities, you might want to implement a UDF, which basically gives you programmatic power out of the SQL syntax and semantics, which is sometimes really nice to use. This is actually an example that I used similarly at the client side. So what we're doing here, that's in line 1. We're again starting off with Scala3. So also all the features that I mentioned earlier are available to you. And then line 2, this is also really nice from Scala CLI ecosystem. You can just use the JS platform out of the box. And now you might ask yourself, wait, we are in big data, we are using BigQuery. Why should we use JavaScript here? Well, and here you see it, of course, the platform itself is based on the great Scala.js library. And let me come back to the JavaScript part in a sec. First, we define an enum, also the feature I highlighted earlier. So starting from line 7, we might introduce some flavors, which might be vegetable, chicken, and so on. And you also see how concise this whole construct is. You can do it also fits really well in the rest of Scala3, so you can do all your pattern matching and stuff like that, which is really nice to have. And now again back to the JavaScript point. So the interesting part is to define those user-defined functions in BigQuery. It's only available for JavaScript, so you can pass BigQuery a JavaScript function, and this is what we are doing on the way. So we will write some Scala because maybe we don't know JavaScript or we like the features of Scala better, and then we can use the compiler or Scala.js to then emit JavaScript code, which we can then use as a UDF in BigQuery. That's what we're doing here. So line 10, just this annotation just says that we later, when this is compiled, we want to have a global or top-level function in JavaScript that can be called, in this case, daily flavor. And what it does is just like some really boring example code. We pass in a string and then just go to the different cases and give out a different option. For example, for the veggie flavor, it's the veggie day. So really boring, but of course it's just to highlight the ecosystem which is available in Scala CLI and also with Scala3. How does it look now on the BigQuery on the actual site? So here also pretty much straightforward. We can just define a temp function, it's called. where we then, we also call it daily flavor. It should return a string. And then the next step, we can set it to JavaScript so that the query understands what it's about. And we can just reference the actual compiled JavaScript file emitted by running these Scala CLI comments. Again, in the repo, there's some more context. You can just kick it off there. I will share the link later. And then you can basically just call the function. So this is now the daily flavor function from within that JavaScript file. All right. And in the end, where it all comes together is that you can then just also use it in your usual SQL language and then call the function. And as a result, you will retrieve the result. Of course, a few disclaimers. You shouldn't go too wild in those UDFs. I mean, you have the full power. With power comes responsibility. So you shouldn't go too crazy because this will also or might slow down your queries if you're having just too much code in there. All right. Now the last component, Kafka, which we briefly went over earlier. And I think, about Kafka, I think it's cool to start with data modeling in general, because this fits really well again into the space of Scala again, I think, because a case class sounds really basic, but it's really powerful, and I really love to use it still. And here in this case, we are just modeling a ramen class. So we have a brand, we have a flavor and price. So the flavor is again our known enum that we went over just a sec ago. And then, so Kafka is a queuing system, right? So you want to pass those representations of your class somehow in the form of JSON in this example. And for that, we can use the new syntax of, or new 3 years ago, as I said already, but still might be new to some. So this is basically implicits defined with the given keyword. And then we can just, in this case, I'm using the ZeoJSON library. We can just have this little derive line here, and it will be available. So you can basically call things like to JSON and also parse it back. For the flavor enum, pretty much the same. So nothing special here, but now we have the option, and this is exactly what we are leveraging here from line 4 and on, that we can basically parse a string from JSON and then derive our case class again, and also the other way around. So if we have a instance of ramen, we can just go in there and parse it to JSON to pass it then later to Kafka. And this value we will also later use when interacting with the producer from Kafka. A little Z stream in here, of course, also not an talk about Zio, but again, I think the idea here is to highlight that you really have this closed echo system, or this closed setup where you can really iterate quickly between different libraries. You can try things out. If ZeoJSON, for example, doesn't work, try Cersei, try other nice libraries. And I think, again, this is the core of productivity, just to have such a setup. Excuse me. So yeah, in this case, we have just a Zio stream, which will produce random values endlessly. And then we map those IDs to have pseudo-random values of our ramen, and we will also emit it to the topic ramen. As I said, pseudo-random, nothing fancy going on here, but we are just choosing between the different brands, also between the different flavors, and having some random prices. In the end, that's actually also what I included in the snippets. You will also have a Kafka UI, and you can have a look at the results. All right, so summary. I think I mentioned this point a couple of times. So it's really crucial for productivity to have such a validation suite where you can really test out things quickly to just keep up also with the fastly evolving business requirements. And as we saw, Scala3 and Scala CLI is a really strong combination for doing this exactly. But still, disclaimer, use what fits best. So I wouldn't advise to, if this is not the usual setup that you or your team is using, to just go for that. So many ways lead to Rome, of course. Yeah, further productivity pointers, Scala CLI toolkit bundles lots of great libraries. And just, this is, yeah, CLI helper I also have in my examples. So thank you. Here's the QR code and the promised link to the code. Arigato. Thank you.
マイヤーさん、発表ありがとうございました。それでは質疑応答の時間になります。質問のある方は挙手をお願いします。よし、どうぞ。
発表ありがとうございました。スカラのコードがあったと思うんですけど、テストはどのような方法で行っている、スカラのコードをテストしているのか、もっと別の方法でテストを行っているのかとか、スカラのテストコードの方がちょっと気になったのでお聞きしました。
Yeah, thanks for your question. Good question. For these snippets, actually, I didn't include any tests, but Scala CLI comes with exactly those features. So you can, from Munit, and I think Munit is pretty much baked in there as well, but you can also use other testing libraries. It's all as the usual flow. And then I think there's a test comment available. So Scala CLI test or something, and it will just focus on your tests that you defined and then execute them.
ありがとうございます。
ありがとうございます。他に質問ある方いらっしゃいますか？どうぞ。
はい、ありがとうございました。小さくスカラ CLI で、プロジェクトというか、スニペットを開発していくっていうのは、あると思うんですけど、これが成長していったときに、将来的にはスカラ CLI やめて、SBT とかミルとかに乗り換えていくっていうことはあるんでしょうか？それともスカラ CLI のまんまずっと使い続けていく、どっちのパターンが多いとかありますか？
Yeah, definitely. This is supposed to start as POCs, like really slow, that you can iterate fast, maybe even in one file, even though you can split across more files in Scala CLI as well. But I totally agree to what you proposed. So usually, if you're done iterating and you notice it's growing, yeah, more than you expected, then you can also use the built-in tools from Scala CLI. There's an export function exactly to SBT, and then you can just go from there and develop with SBT.
はい、ありがとうございます。
ありがとうございます。もう一人くらいですかね。質問ある方いらっしゃったら思いますが、大丈夫そうですかね。はい。では質問じゃなさそう。では、
Thank you.
これで、発表を終わらせていただきます。マイヤーさん、ありがとうございました。